Hi everyone, Tim Ard here with Forest Applications Training Incorporated, and bringing you another episode of Along the ForestApps Road. This will be episode number 16. If you haven't watched already, we have about 15 other episodes out there, and also some Tim's tips that are on our YouTube channel. So please go by and subscribe and watch a few and press like if you like them, and let us know what you think about them in the comments section below. This past week we've been in Mississippi. We did one workshop in Hattiesburg, Mississippi, and then 2 workshops in Yazoo City, Mississippi with the Department of Transportation. Everything went great there, and we were able to have a great location to do some video. So we videoed the inside portion and also the outside tree felling, and it lets you know a little bit about what our one-day program is about. We also have day 2 and day 3, which are hands-on, but this will give you a good idea of what we do in our demonstration programs at Forest Applications. So please take a look. It's a little long, but it's got a lot of information in it if you're interested in chainsaws, and we hope to see you along the ForestApps Road. I think probably 70% of this theory by Ard, 70% of those people that I talk to who are cut by a chainsaw. In most cases, if I go back and look at the equipment or talk to them a little more, I can figure out that a lot of times it was dull saw chain. What happens is, you know, that when you have a dull saw chain, what do you have to do? You got to sharpen it, I know that, but you got to do what? You got to push on it, don't you? It tires you out, it takes pressure to do it, and so if you got a sharp chain, all you're doing is guiding, but if you got a dull chain, you're applying pressure. And oftentimes, if you're cutting through a limb or something like that, and you're pushing on it when it goes through it, and that's hard to stop that momentum. And a lot of times it's our reaction to its action that comes in contact with a leg or arm or whatever. So it's so important that we think through a good sharp chain. And how do you know when a chain is sharp and when it's dull? How do you check it?
Wood chip.
Some people say wood chips. I will agree that that's somewhat you know, an effective way. Although you got to think about it, that if you're into, you know, decaying wood, you're going to get finer chips. If you've got green wood though, and you're close to an end grain, which is like the stumps cut off, you know, you cut it out like this, you always get finer sawdust. If you go in where a limb attaches to a stump, you'll get finer sawdust. And then if you really want to think about it, you know, going crossways, you get a little bit bigger chip, usually about the distance between 2 teeth. If you go on the end of the log like this, you'll get some long chips. You can take them out of the length of a bar in many cases. So it's not as much the size of the chip as it is how fast it's cutting. So, you know, I usually say it's about 1 inch a second, maybe a little slower than that. But if I take a 10-inch log or limb like this, how long should it take me to cut through it? About 10, 15 seconds at the most. I mean, I see them, you know, and they keep going back and forth, everything else, and they're sitting there chain smoking, and they're just wondering, you know, why did this thing cut? And, you know, it's dull. If you don't watch exactly what you're cutting, you're going to end up dulling your saw really quick. And that's what I see most of the time. Wood doesn't dull it a whole lot, you know. You can run a long time in clean wood, but if you start getting into dirty wood, or you hit a rock or the asphalt or sand or whatever, you can end up dulling it. And most of the time, it'd be called damage. It's really damaged chain instead of dull chain. And that to me is part of the issue that we have is we've got to repair a chain in many cases to get it back to cut. There's 5 parts on today's saw chain that if we understand them, it's easy, whatever tool we have, to get it back to operation, okay? And you may not be the one that's supposed to sharpen, but I will say this, if you don't know when it's dull and when it's sharp, you're probably going to do more work than necessary. If I give you a sharp saw and I give you a dull saw, which one are you going to pick up a second time? The sharp one, because it's a lot more work sitting there pushing and pulling on a dull saw. So you have to make a decision whether you're the sharpener or not as to when it's dull and when it's sharp. First one's right here. How many of you actually sharpened a saw before? Anybody? All right, so we've got some. What is this right here and what does it do? Anybody know what it's called and what it does?
I've been told it's a raker.
If you look at some of the older materials and stuff, or even newer materials, it calls it a raker, or technically it's a depth gauge. You might hear it called drag, or you know, those kinds of things, but it's basically a depth gauge. It sets up how thick the chip is that's going to come off the tooth. That sets up how thick the chip is. And so the lower you go with it, the bigger the chip it tries to take, okay? And it's kind of in relationship, because you hear some people say, well, First thing I do, I grind it down or take it off a little bit, make it really cut. But then on the other hand, when you get into smaller or more precise cuts, it starts jumping and it's hard to work with. Out of the box, they're about 25 thousandths of an inch below this part. And this is called the point or the working corner. That's the first part that bites into the fiber and starts the cutting process. And so it's important to know from this height to the bottom of this, that's the thickness you're trying to do. And out of the box is about 25 thousandths of an inch. You might go down to 30, maybe 32, 35, but after that it gets a little bit aggressive. Okay? Now, one thing it causes, have you ever had it start cutting sideways? That's point damage usually, or the depth gauge setting. And the reason why I know that, you can take a brand new chain, put it in the wood, cuts nice and straight, you know. You take a flat file, knock the tips off about 8 or 10 teeth, and on one side it'll start cutting left immediately. Sometimes it doesn't take 8 or 10, just a couple teeth. So when you start looking at it, that damage to that point is the first thing to recognize. You see any damage to the point, it's not going to cut correctly. The second thing that causes it, let's say for instance we sharpen or it's been sharpened, they take a little bit more off the right side cutters than the left side cutters. If the depth gauge is cut the same, which side is going to be more aggressive, the short side or the long side? Watch this. From this point to right here, what happens to the tooth? It goes downhill, doesn't it? So from this point to here, you got a rake that goes down here. So as I sharpen this back, what happens to the point? It gets lower. So if you don't adjust it, I go in a lot of shops and say, well, we don't touch the rakers anymore because that can cause some reactive forces, so we don't mess with it, we just sharpen the tooth. But if you sharpen it back here, what's got to happen? You got to apply more pressure to get it to cut. You have to set this in relationship to the height of the point. The third one is over here. This is called the side plate. It really does the toughest work. It has to cross-cut the fibers. So depth gauge hit, point hit, bites up, and it comes back and it has to rock back and forth this way past the side fibers to sever it. Now, I get questioned all the time, so what size file should I have for my saw chain? And so I asked one of the Oregon engineers several years ago, and they said, well, it's really related to the diameter of the file and the position on the tooth. They said, if you were to take 1/5 or 20% of the cross-section or radius cut, diameter of the file, whatever you want to call it, if you take 1/5 of it, 1/5 of it should be above the point if it's in the proper position, and then it's a visual from that point down to where the file touches should be roughly 90 degrees. So you could use a little bit smaller, a little bit larger file in some cases, and it's where you position it in the tooth that makes the difference. And so if you think about this, that's very important to look for that visual of 90, okay? It's perpendicular to the bar. The reason why I say that, if you look, this is the alternative to it. And I see this a lot of times, people have too small of a file or hold it too low, and it creates what they call a hook. If I take these out, you can kind of see. Move that file out of there, and you'll see a witness mark on some teeth, shows what that side angle should be. If I take this one out, look what it looks like. And I see this quite often on grind, if they use a grinder or handheld, either one. You end up with this big old long hook sticking out there. And that's not correct. If you see your chain looks like that, it's not sharpened correctly. It should be almost vertical, concave but vertical in that area of the tooth. So important. Now this one over here, we see this a lot on pole saws and small climbing saws, and that being that the file is too big or held way back to the back, and so this one is called a back slope. And so that's something that we want to look for on the small chains, so that you actually have that 90-degree vertical. No more than about 5 degrees forward or back would be the proper setting on it. And so that's kind of the side plate. Okay? And it's amazing how people don't realize, but this is a chisel bit file. This is actually one of the first files that was used on full chisel chain, which is flat side, flat top, which is really the designer's first patents. And this little file cuts about 1/8 of an inch flat surface back up to the point of the tooth. Same size tooth as a round file 3/8 chain, but that's the sharpening tool. And it's really smooth and cuts fast. So different size files of how you hold it can still work very well on the tooth. So depth gauge, the point, and the side plate. The fourth one is up here. This is called the top plate. And it sets up the width of the kerf. This angle right here moves this tooth to this side, this tooth to this side to open the width of the kerf up. The kerf is the slot that it's making, allows the bar and chain to go down through it. You usually have a witness mark up there to show you what that front angle should be, and also when you grind it back to here, it's done its due. It's time to throw it away, basically. So that's a witness mark for wear as well as the angles. But that opens up the width of the kerf. And then the fifth one is underneath the top plate. This is called the chisel angle. And this chisel angle is basically the radius by the file, and it more or less it takes and peels the chip out between the cutters. And so it actually takes two teeth to make one chip. If you can look at it this way, if I was to kind of imagine this being a flat chisel, 45-degree beveled edge, and that's usually what we call the chisel angle. Point here, I could even mark it for say 1/4 inch deep if I was putting a hinge, big hinge into a wooden door jamb or something. I would turn the bevel to the inside, start with this point, drive it down in there, the depth that I wanted, and then I'd do that several times to create this vertical. Okay? Then I turn it over this way and do the same thing on this side, the width of the hinge. And then I turn it upright and I chisel out between the two verticals. And if you're going to do a lot of those, use a mortise chisel. Mortise chisel has an angled front end on it, so it pushes it against that vertical cut. So you have a left mortise or a right mortise, just like you'd have with a left cutter or a right cutter. And so it's kind of interesting when you see how that's designed kind of after a thought process of chiseling, flat chiseling. Well, the guy who came up with it, his name was Joe Cox. And this was back in the 40s. He was from Leona, Minnesota. And basically, Mr. Cox, he had a logging operation. After the war in the 40s, everything started drying up. And so Mr. Cox basically told his family, we need to go where the trees are. So in about 1944 or so, they packed up and moved out to the Clackamas, Oregon, outside of Portland. He got a job on a helper handle on a big saw out in the forest. And so more or less at lunch one day, he was sitting there looking at this piece of bark, and it had a wood beetle larva on it. Kind of looked like a grubworm, had these chompers out front. And it's sitting there chewing on this piece of bark. And all of a sudden, it just came to him. Because all the teeth at that time are called scratchers. They had kind of just a little vertical, a little beveled edge on it, and it's just almost straight up and down. Big chain, but little straight cutter teeth. And Mr. Cox saw that beetle and said, wow, that's what we need to do to saw chain so we can reference the width of the kerf. In other words, you could adjust it. So he drove up about bending the top over like that beetle, so they're going like this to be able to open the width of the kerf. He drew it up in 1946, applied for a patent, was awarded in 1947, and by 53 he was producing Oregon Cutting Systems chain out of Clackamas, Oregon. And so he revolutionized chainsawing worldwide. And I always tell that story. He actually watched a bug and came up with the concept, right? But that's amazing, you work with different tools and things, and you see stuff that you might change or revamp a little bit to make your job easier with it or better or faster. And so understanding what he did right there is amazing. So you start thinking through it a little bit. There's 5 parts: the depth gauge, the point, the side, the top, and the chisel. If we understand those, whatever tools we have to work with, we can make it work, because that's how Mr. Cox designed it. So, that's kind of it. So you can come around on the back side up here so you can kind of see. Because I want to discuss this with you, and then we're going to take and look and kind of discuss a little bit about how this works. Let's take, for instance, that you're cutting along and you hit a rock or you hit a sidewalk or something with it, and all of a sudden you've dulled it, right? And you're probably going to dull 2 or 3 in succession. So what do I look for next? I need to take that damage off, don't I? So first of all, a couple things here. This is a 325 pitch, 0.325 of an inch pitch chain. Y'all know what pitch is? This is important if you're out working, all of a sudden you damage a chain or bar or something like that, and you got to go back to the shop, or you need to put in a requisition for it, and you're working a storm or whatever. If you don't take the bar and chain in to match it back up to your saw, oftentimes you'll get something that doesn't match. It has to have the same pitch, it has to have the same gauge to be able to match up the sprocket on the drive system. Now, you can change the whole package out, but you've got to have those matched. The drive sprocket, the bar tip sprocket, the gauge of the chain, and also the pitch of the chain to match those sprockets. One other thing too is a difference in the gauge, and that being that today's saws basically have 50 thousandths or 58 thousandths a 63 thousandths, 50, 58, or 63 thousandths as far as the gauge. But now they've thrown out another one for pole saws and small saws that's 0.043 of an inch. The gauge is the thickness of the drive length that goes into the bar rail. So that's usually 50, 58, or 63, but the new one is 0.043 of an inch. So it's thinner, narrower, and lighter weight. The pitch is a measurement across 3 rivets divided by 2. And so that has to match the tip sprocket if there is one, and has to match the drive sprocket. So those things are something that you have to reference when you start replacing guide bars and chain. Now if you got the original bar on there, you can probably do is just flip it over and read. This will give you a little engraving here, 325 pitch, 66 drive lengths in the bar length, and it's a 50 gauge rail. So that you can match up pretty easy as long as you got the bar working on the saw as it is. This particular chain being 325 pitch, there's 2 different ones. Some take a 5/32, some take a 3/16. And so here in this case, if I lay this out, this is when it's sharp. You can see it matches that file pretty good. But if I put it here, see I took that file and I've damaged the point off of it. Then all it takes is just hitting a little rock or asphalt or something in the tree, and it just takes that point off. So what am I going to have to do? I've got to file it to be able to get that damage off. So what do you think? How many strokes is it going to take as you have filed before? What do you think? One the other day said, all you got to do is make about 4 strokes on each tooth, count your stroke, do 4 strokes on each one, that thing will cut like a brand new one. But you know, I found that it's not always true, because if I take this one, I've got probably a 32nd of an inch of point going. If I take good sharp file and I make 4 strokes, I'm taking some metal out, but did I get the point? No. So 5, 6, 7, 8, I haven't fixed the point yet. So what does that tell me? I think I see a lot of people who file but don't necessarily sharpen. And here I was pushing on, I've gotten almost into the rivet on there. So I have to be careful that I stay the proper height. But that still won't get the damage off of it unless I just file and file and file. And that's the answer is, it takes as many strokes as necessary to be able to put that back in condition. What I do is, and especially if I rock one or something, I'll take a good sharp flat file. I make a couple strokes there to reestablish my point and put my top angle back. Now I've flattened out my chisel angle, a little bit of side, a little bit of point. But now if you look at it, the cutting surface is a very fine layer of chrome, very hard. Underneath here is hardened also, but it's not as hard as that chrome layer. So you got to reestablish that chrome layer so it's going to cut. So the first thing I do is I reestablish that, and now I'm in a little bit softer metal under there. I can feel it holding right up into it. You go from inside to outside with the strokes, and I do it till it smooths out, and I look. If I don't see any light reflecting on that point or down that cutting surface, it's pretty much set. I look for the side being roughly vertical at 90, so that tooth is pretty much ready to go. Or is it? I just shortened it probably a 32nd of an inch. What did my depth gauge just do? It just grew, didn't it? How many of you have one of these? I see a lot of people that, you know, file the chain back and they don't set the depth gauge unless they take a flat file and I take 3 strokes off it. How much do I take off? I don't know. But if I take here with this gauge it and I set it on there, now I can file off whatever sticks up to this 25 thousandths gauge it, and that sets it in proportion to the height. So that keeps it box stock pretty much, and that's important. Every tooth should be the same length because that's what you bought, but it's not necessary. So if you had a situation where you nick 3 or 4 teeth, you could reestablish the cutting surface, and as long as you set the raker, you take the same bite as the one around it, it's going to cut straight. So it can be set very easily. A couple different tools here. This is the standard filing kit. Usually you're going to get some type of guide like this, which guides you need. It helps to strengthen the file, and this one doesn't fit this particular chain. You see I've got a mark across there, 25 degrees, so that keeps me at the proper angle. This keeps it from going too high or too low, so it doesn't hook it or back slope it. And like I say, it gives me some rigidity to be able to hold onto the file a little bit. And then you come back and you'll have a gauge of some type that comes on here and a flat file that you can take damage off and readjust it. So that's one kit type that you'll see. That Oregon, Husqvarna, Steel, they all have something very similar. This is a roller guide. Husqvarna has this, and then also Steel has a roller. It has a little bit different, you have to go back to this type of raker plate. But this sets on and it holds the file. Now this one's not for this particular chain, but it holds the file up on the rollers, and I've got the angle here I can follow. So that's one type of guide. This one has a unique depth gauge setting though. This takes each tooth independently to the chassis of the chain. Now this one doesn't fit this particular tooth, but if you sit here like this, you got a soft and hardwood setting. I usually generally just use the hardwood setting, and that sets each tooth to take the same bite. No matter how long or short it is, it goes from the point down to the chassis of the chain. Works very nicely. This particular tool right here came across, it's produced by a company called Ferd, P-F-E-R-D, and this has a flat file and a round file. And what this does is this sets up, I guess set the other direction. This sets up setting the depth gauge at the same time as we cut the tooth. So this one you've got to flip these files over. So they're right now set up for the right tooth, which is the one I'm working on here. And so this sets up like this, and I file through, and because this sits on the tops of two teeth, as I shorten this tooth back, this goes downhill, touches the depth gauge, and sets it in proportion to the height. So you don't have to have a two-step process. It's a one-step process, and it sets it completely. One thing nice, if I've got damage there, I can then roll back, either one of the guys, I can roll back to the middle of the round file, and I've got a flat file. So I roll it back, I take the damage off, I continue my cut back into the tooth. So I'm applying pressure back, not down. Then I come up against the tooth in front, and I've got it completely set. The depth gauge is even set. So I don't know anything any faster other than a grinder. Grinders do a great job, it's just a lot of people don't like them. Because oftentimes I've had people tell me, I don't like grinder. I took my brand new chain in there, it comes back out, it's all black and blue. I tried to file it, it's hard as a rock, can't even file it anymore. Now, is that the grinder or the grindee? That's the grindee, isn't it? Because every one of them ground coming out of the factory. The difference is they don't overheat the tooth. You see, if you take a grinder, or really it goes back to the operator too, if you take a chain in there that's all beat to pieces on a rock or something, they're going to look at the worst tooth, they're going to set it up, they're going to go, I got to cut it back past that damage. Any damage on the point or any abrasion on top's got to come off. So they take it, and then what happens? Maybe this one's not back that far. And they start cutting the tops, and they overheat the tooth because they take too much metal too quick. And you know, if you heat up metal, what you do? If you let it cool quick, it either hardens it or softens it. So it's something where it tempers it. So you want to make sure that they don't overheat the tooth. So that's one thing. That's why I started this, is working with grinders, because you can take and be able to take the damage off of it, set the teeth somewhat, then put it on the grinder. You don't have to overheat it so badly. And it does work good with hand filing too. This is for the larger size teeth. There's 3 or 4 of them. And then this one is available in 3 different sizes. This one is the same basic concept. It's also created by Ferd. But this sets up, and you got a picture on there, saw turns this way. So this one is for the right side cutters. So here I lay this down, I go from inside to outside. I've got my angles here I can follow. And so I pushed it across, and this sets it, and as that goes down the hill, it touches the depth gauge and sets it in proportion to the height. But this is neat. You can work this side. You don't have to take all the files apart. All you do is just flip it over, and you're ready. And you can even pull from this side if you wanted to do the left side cutter. So it's a pretty neat tool. And so we'll get over there today. If you want to try it a little bit, we'll practice with it a little bit this afternoon. But that's something that can also it can take off your damage too. You can roll back to the middle, take off the damage off the top of the tooth, and work your way down, and it's set just like I did with that one. And Steel also sells that. It's the same exact tool manufacturers at ForestApps. And so it's you'll see it 2-in-1 tool, Steel. And also to change your files, you can open a trunk and be able to change your files out. So it's a pretty neat tool to have. But that's thinking through. It doesn't make any difference whether you stand on your head and do it with your toes. All these different ones will do the job, won't they? Or just a round file and a flat file will do the job. But you got to do what? You got to understand the 5 parts, because that doesn't change. All manufacturers and everything is you take a look at the depth gauge, the point, the side, the top, and the chisel, and all of those have to be pretty much back to Mr. Cox's design to get them to work right. And so that's the key, understanding those 5 parts. We'll see how it works in the wood this afternoon a little bit, and we'll kind of go over a little bit more on those tools he's got for you. Very good. All right. But you see this little picture of the saw?
See how the handle's working? First of all, you want the one for 3/8 chain. This is 0.325 that I have. But you look at this picture.
Y'all's are for 3/8.
Yeah, yours is for 3/8. And so this sets up this way, and then this is the direction you want to file it, and you hold it here, and you've got marks on here that you can line up parallel to the bar, and also this end piece. Okay, and your pressure, if you put it in a vise, your pressure then inside to outside, and you push back against the tooth. Okay, because it's holding on top of the tooth, so you push back against it. And here, if you want to take off damage, you can roll it back to the middle of the round file. You can make a couple strokes to take the damage off, and you can continue. What I do is I'll lift it up and then go down to that last setting. And you don't really have to worry about counting strokes or anything. You make enough strokes to where it takes that entire surface. Try to keep it the same angle as your witness mark.
Now this was a misconception on my part, even growing up logging. Why do I not have to count strokes with that?
Well, the thing is that it's the relationship of the point height to the depth gauge height. So every tooth actually cuts independently, but they all work in conjunction with the loop. So as long as this tooth is taking the same bite as this tooth and this tooth, it's all going to cut straight. And it does it. I mean, this chain's not very old, so it's not really showing up as taking much off. But here you take, and as fast as you go, nice straight strokes. You feel it smooth out, and you check those 5 things that we talked about, right?
If you've ever
Always put on your gloves. The only time I've ever had anybody hurt in training was sharpening. Nice. No gloves. I can't wear gloves. I hate gloves. I can't wear gloves. And slip and slice and dice the finger. And sit here dripping all over. So gloves. And I've even slipped and cut through gloves sometimes. So it's very important that. Now that tooth right there. That wasn't so bad. I'm all messed up and I hit some. She's got gloves. You want to try it on the inside? Out of the chain. Take the damage off with it very quickly. Girl said just roll back, make a couple strokes, take the damage off, and then roll it back down. By the time you get back down to the other tooth, it's set. Well, think about now your position. So first of all, you got, see the arrow?
Mm-hmm.
So that doesn't do that side. So here you go, look, here's the arrow. Chain is on that way, so it is still on that side. And you got to do, which side you gonna do? You're gonna do this side over here, right?
Okay.
No, see the arrow there? That doesn't work.
No.
So we have to do what? So now the handle's that way, and the arrow's going this way. So now remember your angles now.
Mm-hmm.
So you just, back there, it only cuts one direction, that's forward. And if you just practice a little bit, then it gets faster and faster and faster.
Kyle, I think you're getting old of it now.
You do one chain, I guarantee you'll have it.
You can see the difference like in there where it's been used towards the bottom and where it's kind of smoothed out on the other one.
Here, what you want to think about, you need to start on the ground or somewhat other safely supported manner. Air starts like this. It takes a lot of back pressure, it takes a lot of muscle fatigue, and plus, you know, it's hard to keep your footing and stuff and starting on the ground, but the clamp start is what we tend to use. If you never use that, it works very nicely. So clamp between your knees. When you push it up, it kills it, then it goes to the next. So what I'm telling you is anytime you pull the rope on the newer saws, it can start. So make sure you're in the habit of using the chain brake. Works really cool. So here I'm going to clamp start it. So pull through till it runs. This thing will go from the rig steady. Here it leans itself out. Takes about 90 seconds. So here, let's check the whole thing though. Chain brake is on, ready to start. So slow down a little bit. I'm gonna go high speed. That dog's ready to hunt it. She's ready to go. On this bow of the handlebar, it's like a 30 degrees off 90. Okay, so in between there will be a 70-degree face notch, and this one's probably about 84, 85. So I could take and lean in just a little bit more, cut the top a little bit faster, but pretty good shape. Now I'm a little bit shallow on this one as far as depth, but when you start to look at it, a tree shallow, you might lose some in steering side to side, but a shallow one keeps it from going backwards. So if I got forward lean, really doesn't make any difference. If I've got back lean shallower, keeps it from going back. But in a windy day, longer hinge means stability this way. So I could cut back in just a little bit, but I think I'm gonna leave it. So if this were a
There it goes. Nope. Yeah, nope.
Don't let me do it. Oh no. About 80%. Remember that?
On the back, yes.
So if we think about here, we use DBH, diameter breast height, to calculate. But if I was to look at 100% here, it would be what? We had 18 inches up there, but here we got 20 inches, don't we?
Yes.
So that would be 2 inches thick. How long would it be? 16, wouldn't it? If we were measuring off of that. So if I take here, gosh, I've only got 12 inches. So what happened to it?
I think you were higher on the cut on the other side.
Well, what difference does that make?
Because you lower here, it's going to throw your tree on the side.
You think so? What has to change to do that? You know, we talked about you've got a rope in the tree and you start to pull it. What's the rope? It's slack. If I have anything back over here, as long as it's not connected, I will agree with you. If I had fiber right here and fiber right here, there's a chance that it could help the steer it that direction. But if I don't have anything back here, high or low does nothing, because when the tree starts to move, what is it? It's loose. Where does it pivot from?
The hinge.
And it goes from the back to the front. So what caused this to twist to go that way?
The hinge wasn't far enough back.
The hinge wasn't long enough. That's pretty nice. So, if I go with the 90, so if I push trying to feed it, it slows down. Actually, the chain cuts best when you pull back. almost kills you. Oh yeah. So you pull back slightly, and it feeds right
Thank
through.
you.
Well, we talked about chip size. The chips aren't a real good indicator. If it's sitting there and the chain's spinning and it's not going anywhere, it's time to sharpen and get another chain or another saw or something. But watch this now. What's it doing? Raising up. And that's a heavy log in the middle. If it was down closer to the ground, this one's bowed like this. But watch that if I cut through what it does.
You got a wood mod or something?
You see how that wedge did? I can jack it off the asphalt, and also as I cut down through, it's not going to grab your chain. It opens up at the bottom. What's the log jam? This way. I come down the back to the top. I get about right here. What do y'all get?
Right there.
Huh?
0.5.
That's pretty close.
Yeah.
So I'm going to shave underneath one time. Oh, you just say you ain't make no undercut.
Yeah,
yeah. Okay, then I wouldn't do the undercut. Look down that line on top of the saw. See if we're lined up. Lined up. So, I do the top cut first so I can look into the bottom cut. And I want to make it down into the tree enough till I've got 80% of the diameter across the tree. So I got to cut down just a little bit more. Hi y'all, just finishing up the last demonstration here out in the field with the training this week in Mississippi, and we got about 6 hours back to Rome, Georgia. We got the duck about ready to go here in a few minutes, but I want to say thank you for a great week, and we had a lot of great guys in the class, and so it all went very smooth. Felled a couple trees in the demonstrations and talked about a lot of bucking and limbing, and it all went very, very well. So looking forward to getting back home. We got a week around the E-Nest next week, and then we'll be heading out, I think, the following week. We'll keep you abreast of all of our happenings along the ForestApps road, So thanks for dropping by. See you again soon. Bye.